Okay, 10.1 notes. Identify, classify, and label polynomials. Now, a polynomial is just a monomial or a sum of monomials. And we'll talk about the specific definition of a monomial here in just a minute. But for now, we just want to know what a polynomial looks like. So a polynomial might look like this. It might look like this. It might look like this. It might just be that. There are lots of different things that a polynomial can be. But when we talk about polynomial functions, we do have some very specific requirements. Now, a polynomial can be written in the form f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1, and so on and so on. So we would keep subtracting numbers from n until we got all the way down to 1. So we have a sub 1 times x, and then our invisible exponent would be a 1, plus a to the 0, and then x to the power of 0, and x to the power of 0 is just 1, and that's why we don't write that one here. So the things we need to understand here, a to the n, or a sub n, is just our coefficient. And in this case, specifically, it's our leading coefficient. And we'll talk about what leading coefficient means here as well. But for now, all we need to know is that the number right here can't be 0. We also know that all of our exponents have to be whole numbers. So it can be 0, but can't be exponents that are fractional or exponents that are negative. So if you see a negative exponent, you don't have a polynomial function. If you see a fractional exponent, you don't have a polynomial function. Also, all of our coefficients have to be real numbers. And all of the ones that we deal with in this class should have real coefficients. But a non-real number might be a number like this. You can't have a negative under the exponent or under the radical because that gives you an unreal number. But again, most of the ones we deal with in this class will have real coefficients. So this might be an example, 2x to the third minus 4. Is that a polynomial? Yes, it is, because our coefficients are all real. Our exponents are all whole numbers, or 0. This would be times x to the 0, which is just 1. So we have 1 times 4 is 4. And we know that our leading coefficient here is not 0. It's 2. So this is a polynomial. However, if we had one that looked like this, that would not be a polynomial. Because that exponent is negative. And if we have an exponent that's negative, we don't have a polynomial. Standard form of a polynomial is what it looks like when a polynomial is written with the exponents in descending order from left to right. So if we had this polynomial, x to the third minus 4x to the fifth minus 6, is that in standard form? No. This is not standard form. Because our exponents don't go down as we go to the right. We would have to have the 5 before the 3. So in order to write this in standard form, we would switch these two terms around. Now I have to be careful of my minus sign here. That needs to be a negative 4x to the fifth still. So I say negative 4x to the fifth, and then because this x to the third is positive, I say plus x to the third, and then I have minus 6 at the end. Now this is that same polynomial, but written in standard form. So you might be asked to write a polynomial in standard form, or determine if a polynomial is in standard form, what you're looking for is the order of the exponents. Now you could have terms missing. Normally we would have x to the 5th, and then x to the 4th, and then x to the 3rd. Because a term is missing doesn't mean it's not in standard form and not a polynomial. It's just missing that term. Moving on now to classifying polynomials, we're going to talk about those specific definitions of monomials, binomials, and trinomials. Now a monomial is a polynomial with only one term. Remember, terms can be combined by multiplication or division, but not addition and subtraction. So this would be a monomial, or a binomial is a polynomial with two terms that are combined by addition or subtraction. So a binomial might look like this, or that. Two terms combined by addition or subtraction. So this 2x squared by itself would be a monomial. When we add another term or subtract another term, we get a binomial. And a trinomial is a polynomial with three terms combined by addition and or subtraction. So a polynomial with three terms, so a trinomial, might be like this. We have 1, 2, 3 terms. We could have a trinomial like this. 1, 2, 3 terms combined by addition and or subtraction. And it doesn't all have to be 1. This is still a trinomial. We still have 3 terms combined by addition and or subtraction. Now we'll talk about labeling polynomials. Specifically the parts of the polynomial as it's written in standard form, where we have a sub n times x to the power of n. Now a sub n is just a number, and those a terms are all of our coefficients. The sub terms here are just to help us designate them from one another. So the leading coefficient is a to the n, and it is the coefficient of the term with the biggest exponent. So we look for the exponent that's biggest and say, okay, that's the leading coefficient. The degree is the highest exponent. So if your highest exponent is 3, you have a third degree polynomial. If your highest exponent is 7, you have a degree 7 polynomial. And the constant term is this a sub 0. It's this term here at the end. And it's called the constant term because it has no variable part. So if your term has an x in it, it's not your constant term. The constant term might just be 7 or 12 or 132. It's just a number with no variable part. Now some common polynomial functions are listed here in this table. These are going to be important for you to have because you'll need to be able to classify the type of polynomials all the way up through a 4th degree. Now there are some names for degree polynomials after this, but you don't need to know them for this class. You just need to know up through the 4th. The first one we're going to look at is a degree 0. That would mean that our x has an exponent of 0, which equals 1, which means our function then is just a number. So an example here would be f of x equals negative 14. So a constant function is just f of x equals a number. A degree 1 polynomial is a linear polynomial because your only variable part is just an x with no exponent, or an x with an invisible exponent of 1. So when your only variable term has an exponent of 1, you have a linear function. So 5x minus 7 could be a linear function. 12x could be a linear function. You don't have to have that constant term there, but you do have to have the x term there. A quadratic equation or function has a degree of 2. We can see here that our highest term here will be x squared with x as 2. So we can see that this is our highest exponent is 0 because we don't have one. Here our highest exponent is 1 because there's our only x with an invisible exponent. Here our highest exponent is 2, so we have a second degree polynomial, which is called quadratic and might look like this. F of x equals 2x squared plus x minus 9. You don't have to have the x term. You don't have to have the constant term. This by itself, f of x equals 2x squared, is still a quadratic equation. It's still a quadratic formula or function. A cubic, again, just goes up to the third. So this is x squared. Here's x cubed. You only need this cubed term to be a cubic function. If you didn't have anything else here, if this were just f of x equals x cubed, so this were all you had, that's still a cubic that is still a cubic function. It's still a degree 3 because that's your highest exponent. But you can have everything under that as well. And fourth is a fourth degree. A quartic function has a highest degree of 4. So our biggest exponent is 4. And it might look like this. And here we can see an example of one that's missing some terms. It doesn't have an x squared term. It doesn't have an x cubed term. But because the highest exponent is 4, it is a quartic function. So that's how we classify, label, and identify those polynomials.